This lesson is going to cover vector operations and linear combinations with vectors. It's really simple. Let's do vector operations first. And this is the mechanics of vector operations. There is an application for both operations and linear combinations that we could go over. That would be a separate lesson. So this is just the basic mechanics of how to, but the why will come later. So for vector operations, we're going to let vector u, you wouldn't really put that because you don't have an initial and an end. Let vector u equal component form 1, 2. And let vector, I don't know, w equal component form 3, 1. If I wanted vector u plus vector w, then that would result in 4, 3. 1 plus 3, 2 plus 1. It's that simple. If I wanted vector u minus w, u minus w. U is 1, minus w is 3, so 1 minus 3. I'll just write that out. Negative 2, 1. How about w minus u? Three minus 1, 1 minus 2 would result in 2, negative 1. So notice that u minus w is not the same as w minus u, and that's because subtraction is not commutative. How about 3u? That would be 3 times component form 1, 2, which would result in 3, 6. And how about 2u minus 3w? So 2 times component form 1, 2 minus 3 times 3, 1. That would be 2, 4 minus 9, 3. And the result of that is negative 7, 1. That's vector operations. Great. Let's talk about linear combinations. A linear combination just takes your component form and writes it as a line. And it uses these unit vectors. Unit, just like a unit circle, means a magnitude of 1. And unit vectors stack, or vectors are a stack of units that are all going in the same direction. This will be used with an application to find velocity and combined weight. But for this lesson, again, I'm just going to show you how to use these standard unit vectors and we're going to name I. That goes with, as you can see, the X component, and J, standard unit vector for the Y component. As a linear combination, that would result in, so if you, as a linear combination, if you had vector so V1 and V2, then your linear combination would be V1I plus V2J. That's a lot of mathy terms for some very simple concept. Let's try an example so you can see just how easy this is. If I had a vector, I don't know, 3, -5, and that's in component form, and you know that because of the sideways v's. So that's already vector component form. That tells me wherever I start, I travel right 3 and down 5, no matter where I get to start from. That's what this vector is doing. And we want to write that in linear, as a linear combination. Then it would be 3i minus 5j. Done. That's it. So let's start, if you're given an initial point and a terminal point, how would I turn around and write the beginning and ending in a linear combination? So if your initial point is -2, 6, and your terminal point is -8, 3. Well, in order to write this as a linear combination, you have to have the component form first. So first we're going to find the component form. So you're going to do -8 minus, oopsies, a -2 and 3 minus 6. So your component form is -6, -3. Now you can use that to write it in a linear combination. -6i minus 3j. Done. I'm going to give you one more example, and I want you to pause, and I want you to try to do this one, and then see if you get the same answer that I do. If the initial point is 2, -5, and the terminal point is -1, 3. Sorry, I had a blip there. I want you to find the component form, and I want you to find the linear combination. I got the component form -3, 8, and a linear combination of -3i plus 8j. If you did not get that, then you need to double check your math right here. This would be -1 minus 2. It's terminal minus initial. And you'd have 3 minus -5. -2 minus 2, or I'm sorry, -1 minus 2 is -3. 3 minus a -5 is +8.